Hello everyone. Today's lecture is about the early application of nanomaterials. Before this lecture, we have studied about the classification of nanomaterials. So, materials and the nanometer scale exhibit different physical, chemical, and mechanical properties compared to bulk materials. It means that the nanometers the nanometers nanoparticles compared to the bulk materials compared to the large materials exhibit different type of properties. For example, gold, under ordinary condition, is a yellow inert metal capable of conducting electricity. If a centimeter long gold file is taken and broken down a dozen equal pieces, the pieces will still appear golden yellow. However, when the pieces are broken down about a million times into bits just a few nanometers wide, almost every characteristic changes. Nanogolds no longer glitters with the golden yellow metallic lusters. Deflecting light of gold nanoparticles varies in color depending upon their dimensions. Here, here we have the nanoparticles and their different nanometer range and different nanometer size. 50 nanometer particles and the diameter appear blue or purple, while these nanoparticles at the nanometer of 25 they are red, and at 1 nanometer they are orange. Means that these nanoparticles possess different properties while changing with their size. So properties are changed if the size is decreased, that is due to increase in surface to volume ratio. Surface to volume ratio is inversely proportional to size. So could you have imagined that a novel material like gold could actually become highly reactive and be used as a powerful catalyst when synthesized in nanometer size? The melting point of gold also drops by almost 50% when the grain size is reduced below 10 nanometer. Similar changes have been observed in different nanomaterials with regard to a variety of other properties like magnetism and conductivity. So publications on nanoscience and nanotechnology. So there are lots of publications have been made from 1980 onwards, 1985, 1990 to 2010. So these nanoparticles have been used from the very beginning. After the 1980. So according to the applications with the passage of time, their applications have been very important in each and every field of the science. So application of nanomaterials. Nanomaterials are being used in various applications: toothpaste to satellites, number one, cosmetics, textiles, healthcare, tissue engineering, catalysis, functional coatings, medical diagnosis, sensors, communication engineering, water and air pollution treatments. So number first we have electronic devices. So numerous nano electronic applications are in use for communication and computing purposes. It means that on the right side we have the computers, electronic devices regarding computer, the cameras, the micro SD cards, cameras, and these electronic devices, different type of nanomaterials are used for their displaying purpose, for their good quality. Structure and engineering. Nano-enabled products are being developed for wide range applications in the construction industries. Reinforcement of the concrete with the nanoparticles. Concrete reinforced with the nano TiO2 or carbon nanotube has been found to have remarkable increase in strength and water resistance. Self-cleaning glass, safety of buildings against natural and other disasters, sensor to sniff toxic substances, fire resistance coatings, UV IR reflecting windows. So, insulations. Aerogels are materials which are porous, foam-like, and extremely lightweight, and yet can withstand about 100 times their weight. Aerogel composed of silica nanoparticles separated by nanopores is mostly air, making it an excellent insulator. So, insulating the walls of a house would only need about a 1/3 thickness if this material is used instead of conventional insulation. Use as smart windows which darken on a sunny day and lighten on a cloudy days. And medicine. Nanomaterials used in diagnosis, therapeutics, prosthesis, artificial body parts, artificial body parts, materials and tissue engineering. By attaching different biomaterials to nanomaterials, they can be used in medical applications for specific functions. Nanotechnology is being developed for both therapeutic using nanodrug delivery system and diagnostic nanosensor applications. Gold nanoparticles attached to a short segment of DNA can be used to detect the genetic sequence of a sample. So bandages embedded with the cell nanoparticles provide antimicrobial protection and aid faster wound healing. Energy. Some new areas for the use of nanotechnology in this field are to extract hydrogen from water, to harvest energy from the sun and biomass, to store energy as hydrogen fuel cells, batteries, and capacitors. As advanced catalysts for energy conversion, nanomaterials will also impact efficient utilization of energy for industries such as transportation, power generation, and utilizations, cleanup, environmental cleanup. It means that we have different properties of the nanoparticles and different applications in each and every field. Now, the catalysis. Chemical analysis benefits significantly from nanoparticles due to the extremely large surface to volume ratio. Because the nanoparticle has large surface to volume ratio, the surface area to volume ratio is losing proportional to the size of a particle. The larger the surface area, the more active the catalyst. Nanoparticle can be used as catalyst and automobile catalytic converters for the removal of toxic gas inside is carbon monoxide and nitrogen oxide. Carbon monoxide. Thank you so much for this for watching this lecture. And today the next lecture will be about the water treatment and the environment. So the application of these particles and the field of water treatment and the environment. Thank you very much.